Myself, Dr. Somit De, teacher in charge and assistant professor of mathematics section under Department of Basic Science and Humanities, Association College. This is my 10th lecture under module number 3, paper name Mathematics 1A, paper code BSM-101 for Computer Science and IT. The topic is solution of a system of linear equations. Subtopic is Gauss-Jordan method. So there are different methods to solve this system of linear equation. Cramer's rule I had discussed in my lecture number 7. Matrix inverse method in lecture 8. Gauss elimination method in lecture 9. That is last lecture. And now I'm going to discuss Gauss-Jordan method. Cramer's rule based on determinant concept. Matrix inverse method is matrix determinant method, Gauss elimination method, and Gauss-Jordan method. All are based on matrix concept. Okay, but method matrix inverse and Gauss-Jordan basically they are close to each other, because here in matrix inverse method we are finding A inverse by the general formula, that is adjoint by determinant of A. But in Gauss-Jordan, again we want to calculate A inverse by using different techniques. So this is the basic difference between matrix inverse method and Gauss-Jordan method. In this Gauss-Jordan, we have to calculate A inverse separately, then find the value of unknown variable x1, x2, x3. Now, see. So this is a basic difference. Gauss-Jordan method. Let us consider a system of 3 linear equations in 3 variables. In 3 variables x1, x2, x3. So a11 x1, a12 x2, a13 x3 is equals to b1. a21 x1, a22 x2, a23 x3 is equals to b2. a31 x1, a32 x2, a33 x3 is equals to b3. This system of equation can be written in the following matrix form: Ax equals to b. This is equation number A. What is A? A is a coefficient matrix. This matrix is coming from here. The first column of A matrix is coming from coefficient of x1. Let's see, A11, A21, A31, first column. Second column is coming from coefficient of x2, A12, A22, A32, this one. And third column of A is coming from coefficient of x3, that is A13, A23, and A33. This variable matrix, column matrix, the x1, x2, x3 is a column matrix, and this B, capital B, this is also a column matrix, B1, B2, B3. This is a right hand side part. So whatever the given system of equation you have, first you have to write down into this form. Up to this portion, whatever the method you want to apply, all are same. Okay, clear? Now, so this is the basic difference. To solve A, so solve A means this matrix, means this system of equation. Gauss-Jordan method, we consider determinant A not equals to 0, because if determinant A not equals to 0, you can't find A inverse. If equal to 0, you can't find. So that's why first you have to check determinant of A matrix is not equals to 0 or not. Okay, if it is not equals to, if equals to 0, you can conclude Jordan method is not applicable. Directly you can write. If determinant A not equals to 0, then you can proceed further. Now augmented matrix A with the identity matrix of order 3 we have. Why it is order 3? Because your A matrix is order 3. Okay, so that means augmented matrix you should write A matrix, given A matrix along with your I matrix. So that's why I'm separated with by line. So this is your A matrix and this is your I matrix. What is our target? What is our target? So this is already I inform you that this technique is all about the finding A inverse, correct? So this is the all about to you can, this is another way by which you can find A inverse without any adjoint. Try to understand this. first you write down what is your A matrix, then identity matrix. Our objective to transform using elementary row operation, to transform this portion should be identity matrix, and this portion should be another value wise. So if I can get it, then this is called A inverse. So this portion, when you transform this AI to I with something, then something is known as A inverse. So A inverse equals to this portion. Clear? So this is the basic part of Jordan. So this is the main part, not basic, main part. Okay, you are calculating your A inverse without any adjoint, without anything. We are not here, we are not using any general formula adjoint by dating, but you should calculate. Then I think you have a question in your mind, why I'm calculating determinant A? Because if I know determinant A is not equals to 0, automatically I can conclude A inverse exists by default. But if determinant A not equals to equal to 0, you can't find A inverse, so you can't generate this matrix. Okay, so that's why you should check whether determinant A is not equals to 0 or not. If not equals to 0, then you can proceed further. Okay. So here I'm writing in a single line, but there some important lines are required to transform this matrix into this form. So I'll explain later with some example. So the concept is clear. So in Jordan method, our objective to find A inverse from this concept. That is, first you will write down your given A matrix along with the I matrix, then elementary row of portion you have to transform this first portion as a identity matrix and second portion another matrix. So this another matrix is called A inverse. So first you have to calculate A inverse. After knowing your A inverse, just you substitute the solution of the given system equation is x equals to A inverse B. So already you know A inverse from the last calculation, this one. Okay, and then you multiply, you can find the value of x. That is our system of equation solution. Okay, but it's a very easy, but you should understand with some example. Try to understand line by line, very easy. So this is the another approach to find A inverse, as well as another approach to solve a system of linear equation. Now try to understand with some example. Solve the system of equation by Gauss-Jordan method. Be careful about this. Gauss-Jordan method. 2x1 plus x2 plus x3 is equals to 5. 2x1 minus x2 is equals to 0. 2x1 plus x2 minus x3 equal to 0. Now you can see in second line x3 is missing. First you have to rewrite this. The given of system of equation can be written as, first you have to rewrite x always in column wise, x2 same, x3 you have to write 2x1 plus x2 plus x3 is equals to 5. x1 minus x2 plus 0x3 is equals to 0. 2x1 plus x2 minus x3 is equals to 1. Clear? If any one variable is missing, first you have to rewrite this. So this is your first step. The given system equation can be written in the following matrix form. This first column is coming from coefficient of x1, 2, 1, 2. Second column is coming from coefficient of x2, 1, minus 1, 1, 1, minus 1, 1. Third column is coming from 1, 0, minus 1. And this matrix column is coming from the variable x1, x2, x3. And right side part column matrix is coming from right hand side part value 5, 0, 1. So I'm considering this is equation number 1. Clear? So up to this portion, whatever the method you want to apply, whatever matrix inverse method, Gauss elimination method, or Gauss-Jordan method, all for all up to this portion is same. Okay. Next, what is a 2, 1, 2, 1 minus 1, 1, 1, 0 minus 1? From where you have this one? This is your A, this is your X matrix, this is your capital B matrix. Clear? This is your A, this is your X, this is your B. This equation number 1 I am considering. So that means I am substituting this equals to a, this equals to x is equals to b. So that x ax equals to b, x is equals to a inverse b. Okay. Now already discussed that first you have to calculate that determinant a. Determinant of a 2 1 1 minus 1 1 minus 1 0 2 1 minus 1. Now already know how to calculate 2 into minus 1 into minus 1 1 into 0, that is 1. Clear? Minus 1 into 1 into minus 1 minus 2 into 0, this one, plus 1 into 1 into 1 minus 2 into minus 1, this. So from here 2 into 1 minus 0 minus 1 minus 1 into 0 minus 1 minus 0, and second 1 1 minus minus plus 1 plus 2, that is 3, that is 2. From here minus plus 1 and 3, that is 6, not equals to 0. That means A inverse exists. So it means you can apply Jordon. Okay, clear? Now most interesting part and important part. Now the augmented the matrix A with identity matrix of order 3. We have AI. This is your A matrix. This is your I matrix. Clear? So this is your A matrix 2 1 1 1 minus 1 0 2 1 minus 1. Identity 1 0 0 0 1 0 0 0 1. Okay. So what is our target? Our target, this identity matrix should be here after some operation. Try to understand. I'm using very easy technique. Our target to convert this number, I already are familiar with in Gauss elimination method. Our target to convert this is 0 and this is 0. Okay, then write down R2 dash is equals to R2 dash means new R2. Which one fix this? First you write down this line as a whole. Just to consider this is single matrix 2 1 1 1 0 0. You write down first row is fixed. Okay, which row you want to change? R2. This row you want to change. Write down R2 dash. First you write down R2, then you write down R1. Clear? First you write down R2, then you write down R1. Then you check the number 2 and 1. 2 is associated with the R1 and 1 is associated with the R2. Exchange this. Exchange. 2 should be with R2 and 1 should be with R1. Just like I'm using multicolor so that you can understand. I am multiplying 2 with R2 and 1 with R1. Why? Because 2 is with the R1 and 1 is associated with the R2. So that's why just reverse the number. Okay, why it is minus? Very easy. They are same sign. I repeat once again. If they are same sign, write minus. If they are opposite sign, write plus. Please remember, most important information. Okay, now subtract it. Multiply with 2, 2 minus 2, 0, minus 2, minus 1, minus 3, 0, minus 1, minus 1, 0, minus 1, minus 1, 2 minus 0, 2, 0 minus 0. So that means you multiply 2 full and subtract with R1. Okay, now your target to convert this number as a 0. Then what you do? First you write down R3 dash is equals to R3 R1. Then here you have 2 same number. If please remember, if you have a number same number, you should write 1 and 1, 1 and 1. Clear? 1 and 1. Clear? Okay. Then you write then multiply with 1 and multiply with 1, then subtract 2 minus 2 0, 1 minus 1 0, minus 1 minus 1 minus 2, 0 minus 1 minus 1, 0 minus 0 0, and 1 minus 0 1. Clear? So this is all about the second step. Okay, now you can check. You have some negative sign in second row and third row. So we are mainly concerned with the first our main target to convert this first portion as a unit matrix. That means 1 0 0 and 0 1 0 0 0 1. So that's why first you have to multiply with row 2 by -1 and divide by this and R2 by -1. Just to check, R2 dash is equals to R2 by -1 and R3 dash is equals to R3 by -1. That means you are transforming all row, that is second row element, as a positive and third row as a positive. Just to check, when you multiply with the minus signs become plus, this is plus and this is minus. Okay, similarly third row plus, this 2 plus, minus plus, and this was minus. Clear? So now you have this. Now our target, now you have this 2 become 0 and luckily we have this 0. If it is not, you have to convert. If you go through Gauss elimination, you can understand same way, because row operation is same like Gauss elimination. If anything is wrong, then you can inform through mail or through WhatsApp. I can discuss with you. Okay, now second target is our target to convert this is 0 and 0. Our target in next matrix, our target to convert this as a 0 and this as a 0. Then what you do in next, first you have to write down R3 as a fixed number, as a fixed. Which one to change? R2 we want to change and R1 want to change. Okay, be careful. So in this row, in this step, first you write down R3, that is 0 0 2 1 0 minus 1. You write down this. Then you want to change as a 0. How to change? First you write down R2 dash is equals to R2 dash is equals to, first you write down R2, then you write down R3. Why? Because here R3 is fixed. Okay, then you check what you have, 2 1 2 1, correct? So 2 is associated with the R2, 1 is associated with the R1. Reverse it. So 2 should be here and 1 should be here, because 2 is associated with the R2, 1 is associated with the R3. So that's why reverse the number. Then you check both are same sign. So already you know, if both are same sign, you should subtract. If both are opposite sign, you should write plus. So that's why I'm writing minus. Okay, so what you have, 0 6 0 1 minus 4 0. Using this operation you can find it. Okay, same way our next target, this number as a, we want to convert this number as a 0. How? Which one is fixed? R3 is a fixed. So that your number is 3 1 and 2. So 2 is associated with the R3 and 1 is associated with the R1. So you have to rearrange this. Same way, R1 dash is equals to 2R1 minus 1 R3. Why I'm writing minus? 2 and 1 part is clear, because 2 is associated with the R3 and 1 is associated with the R1. Just reverse the number. Why it is minus? Because they are same sign. Clear? So that's why after simplification you have this 4 2 0 1 0 1. After simplification you have this. Okay, what is our next target? Just to check, this 2 becomes 0. What is our next target? Our next target to convert as a this number as a 0. Okay, in next step. So just to check, here it is a 2 and here it is a 6. What is a common? 2 is a common, so you can 3. So that means if I multiply with the 3 with this 2, then we can convert 6, or then automatically you can subtract it. Same way, write down R1 dash is equals to, first you write down R1, then you write down R2. Why it is 3 and why it is 1? Because here 2 and 6, if I multiply with 1 with R2 and if I multiply with 3 with R1, this two number becomes same. So that's why I'm writing R3 with R1 and 1 with R2. Why it is minus? Because they are same sign. So that's why it is minus. If I simplify, what you have, 12 0 0 2 4 2 0 6 0 1 minus 4 1 0 0 2 1 0 minus 1. Okay, now if I want to convert this number as a 1, 12 as a 1, then what do you do? You have to divide throughout the row by 12. Just to check, in next step we are dividing first row by 12. In second row we should divide by 6. Just to check, divide by 6. Then third row we should divide by 2. So now you have this first portion as a unit matrix. So this portion as a inverse. So this is the unique part of this Gauss-Jordan method. Okay, so you may write, if I simplify 1 by 6, 2 by 6, 1 by 6, 1 by 6 minus 4 by 6, 1 by 6, 1 by 2, 0 and minus 1 by 2. What is your A inverse? Now after simplification you have A inverse equals to 1 by 6, 1, 2, 1, 1 minus 4, 0 and 3, 0 minus 1. I'm taking 1 by 6 common from the last step. From this area matrix, I'm taking 1 by 6 as a common. Okay. Now, so you know A inverse is this. So this is the basic difference. Now, from equation number 2, in equation number 2, you have x equals to A inverse B. So you have what is x? Write down here. What is A inverse? This is your A inverse. What is your B? This is 5, 0, 1. Now already you know multiply, how to multiply. 1 by 6 is outside. 1 into 5 plus 2 into 0 plus 1 into 1 in first row. In second row, 1 into 5 minus 4 into 0 plus 1 into 1. Second row, 3 into 5 plus 0 into 0 minus plus minus 3 into 1. If I simplify 5, 0, 1, that is 5 plus 0 plus 1. In second row, 5 plus 0 plus 1. In third row, 15 plus 0 minus 3. So ultimately what you have, 6, 6, 12. If I divide by 6, what is left? 1, 1, 2. The required solution of the given system of equation is x1 is equals to 1, that is this one, x2 is equals to 1 and x3 is equals to 2. So this is the Gauss-Jordan method. So here your main part is finding A inverse. Okay. Thank you. And if you have any doubt in anywhere, you can tell me. Then I'll explain. Thank you very much.